Hello, and welcome to the lesson on 4.6, the fundamental theorem of algebra, the algebra part of section 4.6. All right, there is a graphing part that goes along with it as well, but in this video, we're just going to focus on the algebra part of it. The first thing we're going to talk about is what they call the fundamental theorem of algebra. Sounds kind of crazy, but basically it's just telling you that whatever the degree is, then that's how many zeros there are of the function. All right, so the fundamental theorem of algebra also means an nth degree polynomial function has n zeros. All right, so all we're looking for is the degree, aka the highest exponent, all right, and that will tell us how many zeros our function has, or solutions, or roots. They're all the same. So for example 1, that's all they want us to know. We look at the degree. For example A, the degree is 3. This has 3 solutions, or zeros. For example B, we notice there's 4, so it has 4. And for example, C, that's an 8. Sorry, my paper just spun there. All right, so this one would have 8 solutions. That's all it's telling you to do. All right, that's just kind of showing you what it's really talking about. All right, so we look at example 2 here. It says find all of the zeros. All right, so right now, when the degree is 5, we should have 5 zeros. How are we going to get these zeros? Well, I'm going to make a note. We're going to use a graphing device to help. Right? This will kind of help us narrow down our choices to see where it hits the x-axis, and then we can kind of narrow down the numbers we have to use. All right, so when I look at the graph of the first one, all right, the first one seems like it hits at -1. So I'm going to go through and do my synthetic. All right. I realize that I'm going to need a 0 placeholder for the 4th power. All right, so I bring down the 1, I multiply. All right, so I get 0 as my remainder. So the way I would write -1 as a linear factor would be x plus 1. All right, well, I also look at my graph, and it looks like it hits it at +2. So if I do bring down the 1, multiply, so I also know that x minus 2 would be a linear factor. So what I'm left with is x plus 1 times x minus 2 times x to the 3rd plus x squared plus 4x plus 4 equals 0. Right? If we think we started with something to the 5th power, we took 2 x's out, that's going to leave us x to the 3rd. The reason I did that is I can kind of see that this polynomial here with 4 terms can be factored by grouping. So when I factor that by grouping, I would take an x squared out of the first thing, and that would leave us with x plus 1. I would take a 4 out of the second pair, and that would leave us also with an x plus 1. So this would leave me with x plus 1 times x squared plus 4. Now, a lot of you are going to want to factor this further. You actually can't, because it's not the difference of squares. This is the sum of squares. Okay, but what we're going to do now is set them all equal to 0. So I would say this first one would be x plus 1 equals 0, x minus 2 equals 0, x plus 1 equals 0, and x squared plus 4 equals 0. So I would get x equals -1, x equals +2. We already showed that with these up here. All right, I would get -1 again, totally fine. And now with the last one here, I get x squared equals -4, and if I take the square root of that, oh, you guys guessed it, this is going to be plus or minus 2i, okay, because we can now have complex zeros. This will not hit the x-axis, but it is still a 0 because it's to the 5th power. So our 5 answers are -1, 2, -1, +2i, and -2i. All right, so we're just adding the complex numbers into our possible solutions. All right. If we look at example B here, all right, when we look at example B, all right, we know that we should have 5 zeros again. All right, when I go through and look at it, to me it looks like it crosses it at 1. So I'll use 1 for my first setup of synthetic. Remember to use your 0 placeholder for the X. 1, 1, 4. So this would be X minus 1 as our linear factor. Now it also looks like it hits it at -2. So I bring down the 1. So X plus 2 is also a linear factor. Now, I know something about this graph that we're going to learn going forward, but it actually hits it at -2 twice. So I'm going to use -2 again, and we'll kind of get into that in a little bit. So 1, -2, 0, 0, 9, -18. All right, so I have X plus 2 again. So what that leaves me with is X minus 1 times X plus 2 times X plus 2 plus what I have left here, which is going to be X squared plus 9. Okay? Once again, just like the previous one, we need to be careful. We can't factor this because this is the sum of squares, not the difference of squares. And now if we solve each of these, this one will give us X equals 1, X equals -2, X equals -2. And now just to show you this last one, it should be a 0. All right, we'd have X squared equals -9. We would take the square root of each side, and this would give us X equals plus or minus 3i. That's the square root of -9, because the square root of 9 is 3, and the square root of -1 is I. So we get our 5 zeros. Right, we have 1, -2, -2, positive 3i, and -3i. All right. You could also rewrite this as X plus 2 squared to kind of show you, but totally fine leaving it either way. All right, so 2 more examples like this. All right, which it's going to be kind of nice here because if we look at it, all right, for example C, we should only have 3 zeros because our degree is 3. All right, when I go through and look at this one, it looks like it hits at -4, or crosses the x-axis at -4. So 4, -16. All right, this would be positive 60, 9, -36. And we get 0 here. So this first factor, or the first 0 is -4. So that would be X plus 4. All right, it also looks like it hits it at 3. So if I now use 3, that would now be X minus 3. And now if we look what's left over, we would have X plus 4, that one here, times X minus 3, that one here, times 4X minus 3. All right, same thing here when we do 4X minus 3. We're just going to solve this one. So X should equal 3/4. This one's -4, and this one's positive 3. All right, we should have our 3 zeros, which we do, -4, 3, and 3/4. Okay, so that one's nice. It didn't have any imaginary numbers for us to deal with. Okay, all right, when we look at example D here, we should have 4 possible zeros. All right, but I noticed something right away here, that each term has an X in common. All right, so I'm going to factor out an X first, so we can actually say K of X equals X times 2x to the third minus 3x squared minus 32x minus 15. Now I only have to do synthetic with that remaining trinomial. When I look at this one, this graph, it looks like it hits it at -3. I use my synthetic. We get zeros at, so -3 as a linear factor would be x plus 3. Our zeros at -3. It also looks like it hits it at 5. So I'm going to use 5. So that would be x minus 5. And now what that leaves me with is, don't forget the x out in front, x plus 3 times x minus 5 times 2x plus 1 all equals 0. So we would now have x equals 0, x equals -3, x equals 5, and x equals -1/2. All right, and just remember that would be 2x plus 1 equals 0. And that's how I would get x equals -1/2. All right? So you could actually just go through and do the synthetic again, and then you'd be left, all right, you could factor out an x at the end. Doesn't really matter how you do it. Understand, we have 4 zeros. Here are 4 zeros. Okay? All right, last two things. All right, in the last section, we learned about the irrational conjugates theorem. Now we're going to learn about the complex conjugate theorems. Irrational numbers and complex numbers always come in pairs, because the only way we can get the solution is by taking the square root, and square root values come in pairs, like the plus and minus version. So this is just telling us that if we have a plus bi as a 0, we also have a minus bi as a 0. All right. All this verbiage here is just basically saying we're going to write the simplest equation, all right, with a coefficient of 1. It's just like we did in the last section. So if we look at this and it tells us that 0 is at -2 and 3 plus I, we also need to remember that 3 minus I is also a 0 here. All right, so when we go through and write this, right, we're going to set up our zeros. So -2 as a 0 is x plus 2. All right, now I'm going to write my first 0, so x minus 3 plus I. My third 0, my second pair here, is x minus 3 minus I. All right, and if we remember the trick that we did in the last section, we can rewrite this as x minus 3 squared minus I squared. All right, we have to distribute this, or we have to multiply this, or square this and multiply it by itself. That will give us x squared minus 6x plus 9. I squared, if you remember, is -1. So this is going to be minus -1. When we combine our like terms, we would get x squared minus 6x plus 10. And now we're just going to multiply those two polynomials. So we have an x and a 2, an x squared, a -6x, and a 10. X to the third minus 6x squared, 10x, 2x squared minus 12x, and 20. So our function would be x to the third, -6x plus 2x is -4x squared. 10x minus 12x is -2x plus 20. And there's our function that has the zeros as given. All right, our last example of the day. All right, same kind of thing. Now it tells us it has zeros of 5 and 1 plus 2i. Well, that's also going to tell us that we have another 0 at 1 minus 2i. So if we start off by writing our zeros, to write 5, we would do x minus 5. Then we do x minus 1 plus 2i. And then we'd also do x minus 1 minus 2i. here's our trick that we learned in the previous one. This is going to be x minus 1 squared minus 2i squared. All right, so now we'd have x minus 5. When we square x minus 1, it would give us x squared minus 2x plus 1. All right, when we square 2i, remember we're squaring both the 2 and the I, so 2 squared is 4, I squared is negative 1. This will actually be negative 4. When we combine our like terms, we get x squared minus 2x plus 5. And now we're just going to multiply our polynomials. All right, we have an x, a negative 5, an x squared, a negative 2x, and a 5. X times x squared is x to the third. X times negative 2x is negative 2x squared. X times 5 is 5x. Negative 5 times x squared, negative 5x squared. Negative 5 times 2x is 10x. And negative 5 times 5 is negative 25. So our function, they wanted to use f here, is going to be x to the third. We combine our like terms, minus 7x squared plus 15x minus 25. And that has zeros of 5, 1 plus 2i, and 1 minus 2i. That will do it for today's video. Please let us know if you have any questions. Have a great day. We'll see you guys soon.